Okay, take a look at these here. 6 and 8 are true. Make sure you're understanding how it's talking about asymptotes. 18 is infinity, 20 is negative, 22 is 1, 24 is 2, and then 26 is 1. I want to take a look at 45 and 47 real quick here, if we don't have any questions. Okay, for 45, Maggie Purdy, you get the equation there?
F of x equals x plus 1 over x squared plus 5.
All right, well, what's the answer? Okay, for this one, when you go through the Madison, do you know what the horizontal asymptote is?
Oh, the answer y equals 0.
Y equals 0. All right, now, how do we go about figuring that answer out? Okay, how do we go about that? And we went through just a little procedure yesterday. You take the highest exponent, x squared, and you divide everything by that. Okay, and so you get x squared over x squared plus 5 over x squared. And that becomes 1 over x, because those cancel, plus 1 over x squared. X squared over x squared is 1 plus 5 over x squared. All right, what do we do after this point? We take everything, we divided it, and then we said what? Okay, right.
Let x go to infinity.
Yep, we're going to blow x up. Let it get really big. Let x go to infinity. And how is it going to affect each term? Well, that means 1 over infinity is going to go to 0. So basically we say it equals 0. 1 over infinity squared, that's going to go to 0 too. And what about 5 over infinity squared? That is going to equal 0. So the only thing on top is a 0, and I do have a 1 in the denominator. Okay, so that is what is going to happen. Now we're going to figure out a way so we don't have to do that whole mess. Okay, now it is on, let me do this now, I think. All right, take a look at this, the sheet there, the one that's not stapled. We're going to just go through how just to look at it and tell how to look at it. Like, it's really easy. Once you figure it out, it's really simple. You don't have to go through all this work, but you haven't really seen it, so it's easy to make mistakes. Let's see. The top just goes through the definitions. All right, go to where it says asymptotes of a rational function. Okay, right underneath that number 2 there. Let f be a rational function given by f of x equals p of x over q of x. All right, now p of x, that's just a general polynomial. It says a sub n to the x sub n plus a sub n minus 1, x sub n minus 1, right? All the way out. And then what's the bottom one say? It says b sub m to the x sub m plus b sub m minus 1, x sub m minus 1 plus. All right, what's the degree of the numerator as that's written? Aaron Hess, what do you think? What's the degree of the numerator? N. Yeah, that'll be the highest exponent because it goes n minus 1 all the way down to 0. So the numerator is degree n. What's the degree of the denominator? It is degree m. Okay, so that's what's going on in this case here. Now it says, number 1, it says where p of x and q of x have no common factor. So that's where you don't get something to cancel and you end up getting like a hole in the graph or some different things. So nothing's going to cancel at this point. All right, number 1, the graph of f has vertical asymptotes at the zeros of q of x. You've done that for a long time. You're pretty comfortable with that. Where does the denominator equal 0? Well, that's where our vertical asymptotes are. That's not the issue. The issue is number 2. All right, here's what's happening. The graph of f has 1 or no horizontal asymptotes determined as follows. You can't have 2 horizontal asymptotes. You can have 2 vertical. You can't have 2 horizontal. All right, part A. If n is less than m, Well, if n is less than m, they're talking about the degree. If the degree of the numerator is smaller than the degree of the denominator, then what is going to be my asymptote, horizontal? It's automatically going to be what? Y equals, what does it say? 0. Y equals 0. Now, all right, what's that look like? So if I got, I'm going to call it g of x, 3x plus 1 over 7x squared plus 5. Is the degree of the numerator smaller than the degree of the denominator? Yep. Automatically going to be y equals 0. We don't need to go through all that mess where we divide by everything by x squared. That's just kind of build that up. That's why that works. And it doesn't matter as long as that is less than. So h of x is equal to 2x squared over quit using 7. 3x cubed minus 5x plus 2. Doesn't matter. Both of those will have a horizontal asymptote of what? 0. Okay, as long as the degree of the numerator is less than the degree of the denominator. All right, what about part B? What if the degrees are equal? All right, read through that. What if the degrees are equal? All right, it says if the degrees are equal, then you get this little statement. The line y equals a sub n over b sub n is a horizontal asymptote. Make sure you know how to interpret that. All right, so for that one there, 3x minus 4 over 2x minus 1. What would be the horizontal asymptote? Or what do you think it would be based upon that information? Jacob, you know this or not yet? Or are you just moving ahead without me?
I was just moving ahead.
Oh, moving. All right, sorry. Don't let me interrupt you. Keep going. All right, Lane.
3 over 2.
3 over 2. So this would have a horizontal asymptote of 3 over 2. All you have to do is take the coefficient of the highest degree and divide those. That is it. That is how your horizontal asymptote works. Piece of cake. Just be careful here. Now, what about g of x? What would that be? Okay. Are they the same degree? First of all. Yeah, right? Numerator is x squared. Denominator is x squared after you multiply it out. But here, don't take the first term as whatever. So this would be a -4. And what would be the leading term of the denominator? 2. So -4 divided by 2 would give me y equals -2. Make sense? Okay. So here's what it boils down to. If the degree is less, numerator is less than the degree of the denominator, y equals 0. If they're the same degree, you just look at the coefficients. Okay? But what's part C say? It throws things a little bit of a wrench here. If your degree of the numerator is bigger than, if n is bigger than m, so f of x equals 7x squared plus 3 over x minus 1, what's it say here? Then there is no horizontal asymptote. There can be different types of asymptotes we don't get into a lot, but we will go over one where it's called an oblique or slant asymptote. I don't know if we'll get to it today, but maybe. But that has no horizontal asymptote. All right, so that's all your horizontal asymptotes. Now, below there, it says guidelines for graphing rational functions. You're going to have to graph these without your graphing calculator. Okay? And this is an excellent little step-by-step procedure. I actually, on 1 through 4, I don't necessarily go in the order they go in, but 1 through 4, they're all interchangeable. We need to know, and here I'm going to go to the guided notes here. We're on vertical asymptotes. We did that. We just kind of hopefully cleared anything up on horizontal asymptotes. And now we're going to graph rational functions. Okay. All right, let's take a look at that first one. Now, I think your domain and range is listed at the top. I'm going to wait till the end to do that. And it goes, now I got vertical asymptotes, horizontal asymptotes, x-intercepts, and y-intercepts. And I know on this little sheet it goes in a different order than what I have up here, but I kind of like to find the asymptotes first, then find the intercepts. It really doesn't, one doesn't affect the other. All right, the vertical asymptotes, that is actually number 3 on that little list. And this is kind of the first thing I go to. And you know how to do the vertical asymptotes, is where the denominator equals 0. So it's where the denominator equals 0. And so that's x equals -1. Make sure you write it as an equation. Asymptotes always need to be dotted lines because they're not part of the graph. So at x equals -1, draw in a dotted line. And so let's see here. All right, there you go. X equals -1. That's the only vertical asymptote, right? We just went over that whole spiel about horizontal asymptotes. I don't know if anything's sunk in or not, but that would be on the sheet. They say that's number 4. Find and sketch the horizontal asymptote. Well, I like to go vertical then horizontal and get the asymptotes. That is where you use the rules. All right, Tyler, do you know what it is?
2.
It's going to be 2. You take a look at your coefficients. They're both the same degree. 2x over x, y equals 2. And you're going to draw in horizontal asymptote. All right, x-intercepts. That is actually 2. All right, I want you to think. How do you find the x-intercepts? How do you find the y-intercepts? X-intercepts. If you look, you can look at that, or you can go back into your knowledge base. According to this, how do I find the x-intercepts? Or according to the sheet. All right, Nathan Moore, how about it? What do you think?
I'm not sure.
All right, look at number 2 there under that. You see where, are you following me on these guidelines for graphing rational functions?
Yes.
Okay. To find the x-intercepts, you find the zeros of the numerator. So we want the numerator to equal 0. So for the x-intercepts, okay, that's going to be 2 times x plus 3 equals 0. 2 times x plus 3 equals 0. Solve that. Figure out what x is.
-3.
-3. So you get 2x plus 6 equals 0. 2x equals -6. X equals -3. All right, make this -3, 0. Plot that point on your graph. -3, 0. All right, y-intercepts. This goes way back. So let numerator equal 0 for the x-intercepts. Y-intercepts. Hey, how do you find a y-intercept in any graph? Plug in what? 0 for x. Plug in 0 for x. Never, never, never changes. Let x equal 0 for everything. For everything. So f of 0 equals, let me look up here, 2 times 0 plus 3 over, what is that? 0 minus 1, 0 plus 1. And 6. F of 0 equals 6. So that is the point 0, 6. Plot that. 1, 2, 3, 4, 5, 6. All right, read step 5. Read step 5 on that little list. we're gonna make a little XY chart. Because right now, I got 2 points. That doesn't really give me enough to confidently graph this point. So we need to come up with a couple points. You really cannot use too many, but you can use too few. Based upon what it says pick X values between and beyond the X intercepts and vertical asymptotes, right? And plug those in. Between and beyond. So whatever's the furthest to the left, which is -3, I need to pick 1 point to the left of that. Doesn't matter. Now don't go crazy, plug in -100. I usually plug in the next one or the second one after that. So I'm gonna plug in 1, 2, 3, 4, -5. We're gonna plug in -5. I gotta plug a point in between this x-intercept and that vertical asymptote. Well, there's only one whole number. If it's not a whole number, you gotta pick a fraction. That's -2. All right, and then what else? And you need to pick 1 point on the other side. We already know where the y-intercept is. So pick a point to the right of the vertical asymptote, but not 0. So I'm just gonna go to 1. All right, plug in those 3 numbers and see what you get back from your equation. A lot of times they're gonna be fractions, they're gonna be decimals, you're not gonna get nice whole numbers. Really, really watch the signs. Like, is it positive? Is it negative? And so forth. Okay, so plug those in. You've got, and this is the case here, you've got to have at least 3 numbers for this problem. For me. If you think you need more, you can do more, but you need at least these 3 numbers. Okay, good luck. Okay. All right. Mia, what do you got? You got all 3 yet? Doing the last one? All right. When you got it, let me know. What do you got?
For -5, I got 1.
Okay.
I got -2, and I got
Then 4. So -5, 1, 1, 2, 3, 4, 5, 1. -2, -2, and then 1, 4. Now remember, you cannot cross a vertical asymptote, so you gotta have 2 distinct faces. The horizontal asymptote, it has to be approaching it on the left and the right. This gives me enough information to figure out what's going on. Also, x-intercepts, it cannot hit the x-axis anywhere else other than where we said the x-intercepts are. So it cannot make any funky twists and turns and then cross the axis somewhere else. It can only hit it right there. The only way we can satisfy all these conditions is if it looks like this, and it goes down, and then this part here, be careful, it hits at that y-intercept, and then it will go towards 3 there and extend that up, and it will travel, vertically along the vertical asymptote. That's what a vertical asymptote means. It has to travel along it, okay, either going up or down. Now, domain cannot be, in this case, -1. So -infinity to -1, union -1 to infinity. All right, now, it can hit the horizontal asymptote, but it doesn't have to. In this case, since it's approaching it from below and it's approaching it from above, it will not hit that value. So it does miss 2. So it will be -infinity to 2, union 2 to infinity, okay, for those. All right, now, these graphs, take all kind of different shapes on. Okay, which I kind of like. You may not, I don't know. But all kind of different shapes. So for this one here, first of all, I would factor the denominator into x minus 3 and x plus 2. All right, first thing, see if you can find the vertical and horizontal asymptotes. Okay, see if you can identify those. All right, Emily, how about vertical asymptotes? What do you think?
X equals negative 2 and x equals 3.
Good. X equals negative 2. Hold on. X equals negative 2. X equals 3. Write them out, separately. Draw in vertical asymptotes there. Both are dotted. So negative 2, positive 3. You got to have 3 pieces now to this graph. You cannot cross a vertical asymptote. Horizontal asymptote. Josh, Martin, what do you think?
I got 0.
You got 0. The degree of the numerator is less than the degree of the denominator. Automatically makes it 0. Now, you can't draw a dotted line over an axis. So here's what you do for this. We do what's called crosshatches. You just kind of make little slant or little diagonal lines on there just to indicate that you have a asymptote there. Okay. All right, so now those you tend to be okay on those x-intercepts. Just people forget. How do I find the x-intercepts? All right, Mackenzie, do you still remember?
You let the denominator equal 0.
That's vertical asymptotes, but you're on the right track.
Wait for what?
X-intercepts.
Oh, the numerator.
Not the denominator, but the numerator. Let the numerator equal 0. So I'm going to write that out a couple of times because that just tends to be the one that people forget the most. X-intercepts. Let numerator equal 0. What's my numerator? It's just negative 3x, right? Negative 3x equals 0. X equals 0. Gives me the ordered pair. Zero, 0. So I'm going to put that point right there. For the y-intercept, Adam Lippy, you remember how to do that?
You let x equal 0.
Yeah, let x equal 0. Well, what's that give us? Gives us what? 0 again. So typically, if your x-intercept is 0, 0, your y-intercept has to be 0, 0. And that's okay. All right, now here's the key. You have to pick certain points. And if you pick too few, then you're gonna. I have to take points off. Don't blame me. Trying to help you out. All right, between and beyond. So I got to have the vertical asymptotes and the x-intercepts. So the furthest thing I know on the left is this vertical asymptote. I need 1 point to the left of negative 2. 1 point. I'm gonna pick negative 4. You can pick negative 3, whatever. Just 1. What's the next point I gotta use? Let's see if I'm making any sense. I gotta use negative 1 because it's between the x-intercept and the vertical asymptote. Negative 1. What's another point I gotta use? Okay, I gotta use. Listen, Ryan?
1.
1 or 2. Doesn't matter. 1 or 2. And I'm just going to put them both down. Somebody, like, you got 2 people, one of you do 1, one of you do 2, just so that you have two values. Okay? Again, and I'm not done, though. What else do I need? Okay? I need one more.
Like 4.
I need 4. 1, 2, 3, 4. I need something to the right of that asymptote. So 1 and 2 are interchangeable, but you need to have negative 4, you need to have negative 1, 1 or 2, and then 4. All right, plug those in, see what you get. You can plug them into the original, or you can plug them into the factored form. I don't know which one's easier. -3x. Now, just a little forewarning. You will not have any calculator on the first part of the test, which includes these problems. So while you're typing all this in your calculator, which is perfectly fine, make sure you can do it without it. Which means you just gotta be able to take your time, plug those in. Yeah, not nice numbers, but that's okay. Okay, -4, I'm just gonna plug this one in. And like I said, it doesn't matter whether you go to the original or you go to the factored form. So some might be easier for one or the other. So I kind of go here, -3 times -4 will give me 12. And then -4 squared is 16, minus -4 is +4, minus 6. And so what do I end up with? 12 over 14, which reduces to 6/7. So you gotta get that. Now, if you want to do it in the factored form, so that's -3 times -4 again. That's positive 12. -4 minus 3, -7. -4 plus 2, -2. That gives me 12 over positive 14, which is, you really got to watch your signs, because if you get a sign wrong, then your graph's going to look, it's going to be really difficult to try and piece your graph together. So I got 6/7. Okay. So it doesn't come out to a great number. That doesn't matter. I'll plot it here in a second. All right, Cooper, how about -1?
For -1, I got -3/4.
-3/4. All right, how about for 1, Gavin?
1/2.
1/2. How about for 2, Kayla? 6/4. Can I reduce that to 3/2? Right, appreciate that. Peyton, Raider, how about, oh, did you get 4? You weren't there yet. Or did you get it?
I did it mentally and then graphed it, so I don't know exactly.
Oh, so how am I gonna check it? Can't grade your mental math. Josh, what do you got?
I got -2.
-2. So right there. And so I'm serious about that, because you'll have to do a chart on the homework, which I know you'll probably do it then, but just for now. All right, so -4 6/7. 1, 2, 3, 4. Close to 1. -1 -3/4. 1/2. 2, 1/2. 4, 1, 2, 3, 4, -2. You got 3 separate pieces, okay? You cannot like cross that vertical asymptote. From this one measly little dot, you should be able to show me what's going on with that piece right there. From that one dot, can it at all? Can it do this? Could that happen? Lane? Say no.
No.
No, because we know all the x-intercepts. We got one x-intercept, which is 0, 0, right? Cannot cross again. It cannot cross that axis again. So it has to be stuck up here. So it's going to look like this. It has to either move vertically up the asymptote or it needs to go vertically down. So there's no way it can go down because it has to cross the x-axis. All right, now I got these points. It hit 0, 0. That is a point. So it has to look like this. And this last one through that one little measly point, the only thing that can happen would be that graph right there, that picture. Domain, what do you think on that domain? It doesn't include -2 and it doesn't include 3, negative infinity to -2, union -2 to 3, union 3 to infinity. All right, what about the range? What about the range? Full roads.
Negative infinity to 0, union 0 to infinity.
Why doesn't it include 0?
It's horizontal asymptote.
But isn't there a point right there?
Yeah.
Okay, what did we write down yesterday? You can cross a horizontal asymptote. You can cross, you can touch, you can hit a horizontal asymptote, okay? So it is negative infinity to infinity. Okay, watch that. That point, it's okay. It just tells you that to the left and to the right, you're approaching that. You can hit a horizontal, and I hit a vertical. Okay, so just be careful of that. All right, here's what I'm going to do. We always get a little bit ahead in here anyway. Just do number 3. Do number 3. When you are done, it does look a little goofy. Okay, it might not look exactly the thing. See if you can figure it out. And when you're done, graph it on your calculator. See if you can figure out what's going on and see if you got it correct. Okay. So do your horizontal, do your vertical, X, Y intercepts, all that. And then see what it, and you gotta make sure you pick the proper points. And that's it. Once you're done, you're done. Alright, graphically back to see if you guys right. Yeah. Wait, there's two different pieces. You can have, you can, for every vertical asymptote, like it'll split it, so that splits it into 1, 2, 3, so you have 1, 2, 3 pieces, but you don't have that vertical asymptote. Well, what'd you plug in? So we plugged in 1, you got back 2, right? Yeah. How can you plug that in as well? Plug in a half, what's a half to you?
0.2 repeated,
Okay, that's a positive number, right?
and then 1.5 gave me 18.
So they didn't give you anything down there, did it? No. So we can't have anything down there.
Okay.
So we're just going to give you numbers back. Alright, graph the calculator, see the matches. When you get down or you get stuck, graph it. Okay, and then see if you can kind of make everything fit together, and if you didn't do something wrong, you can figure out why. Yeah? Good. Great.
Yeah.
Domain and range? Yeah, you were fix that range, and I agree with the domain. Fix that range. I'd always wait till you're done graphing to do the range. For sure.
I got one.